The first type of transformation we're going to look at is translation, and in previous years you knew this as a slide. Up here we have our nice little textbook definition, but as I just stated, it's basically nothing more than a slide, just a new term for it. So from here on out, it's always going to be referred to as a translation. What we're doing mathematically now is keeping track of how we're moving our translated object. And we can take a look that we have moved our shape, our triangle here, over 5 up 0. So this ordered pair tells us how far we've moved it, right or left, first coordinate, and then the second one tells us how far we've moved it up or down. Now of course we haven't moved it up or down, so that's why it's 0. Now in your textbook you'll be able to determine how far a shape has been translated by picking a corresponding side. Because it's a right triangle, I'm just going to pick my right angle here to keep track of, and I'll just count over 1, 2, 3, 4, 5. And of course we have a translation of 5, 0 already. I could have done this with any of the vertices, but again, it's just easier to do it with this right angle. Let's take a look at this problem now numerically without actually graphing any new shape. I've gone ahead and plotted my points because I'm going to need those coordinates in order to do this math. So A is 1, 5, B is 1, 1, and C is 3, 1. Now what I'm going to do is I'm actually going to add the translation to each of the original coordinates. So I'll add my x coordinates together and my y coordinates together. So here are the translated coordinates. I'm using prime for each of these because this is a copy of the original. So it's a translation of the original. So A prime, 1 plus 5 is 6, 5 and 0 is 5. B prime, 1 and 5 is 6, 1 and 0 is 1. And I won't drag you through C and C prime. But that's all it is. All you do is take your translation and you add it to your original ordered pairs in order to find out what your translated ordered pair will be. Here's our plotted points, 6, 5, 6, 1, and 8, 1. And after we connect our dots, here is our translated triangle. Let's take a look at a second example as we translate it. We'll go over 3 to the left and then 6 down. And just like our first example, we'll go with the second example. We'll match corresponding vertices. So picking our right angle again, we're going over 1, 2, 3. And because this is left to the left, it's going to be negative, so it's negative 3. And then 1, 2, 3, 4, 5, 6 down. So that's where we get the translation of negative 3, negative 6. Take a look at this one in terms of the mathematics. So we'll go ahead and translate our triangle here, negative 3, negative 6. Here I've set up my coordinates with A, B, and C. I'm going to translate this object, negative 3, negative 6, so I'm adding negative 3, negative 6 to each of the original coordinates. My new coordinates will be A double prime, B double prime, and C double prime because I've already done a translation of this object already once, so I want to use a different marker for this new shape. Here I've added my coordinates, so I've added my x with my x to get negative 2, my y with my y to get negative 1, and I've done this with all 3 coordinates. And here I've plotted those points. There's negative 2, negative 1, negative 2, negative 5, and 0, negative 5. So the last step, of course, would be just connect the points. And here is my translated shape with the corresponding vertices labeled, as you can see, A double prime, B double prime, and C double prime. So, things to remember: to translate an object, you're just going to take the ordered pair and you're going to add it to the coordinates of the point that you want to translate.